Hi, so I will be walking through question 3 of round 1 of the Maths Olympiad. So at first this question can be a bit daunting, as you would never solve an equation like that in A-level maths, but after a while it may become clear to you how to solve this equation. So there's 3 cases of where another number to another number equals 1. If we let the base of this expression equal a and the exponent equal b, then we can try find the cases when a to the b equals 1. Well, the first case is when b is 0 and a is not 0, then for all values of a and b, a to the b will be 1. The second case is when a is 1 and b is a real number, then for all values of a to the b will equal 1. And the third and final case is when a is minus 1 and then b is an even number, then a to the b will be 1. So if we look at the first case, when b is equal to 0, this means when the exponent of, which is x squared minus 34x plus 240 equals 0, a simple factorization can be seen of x minus 24 times x minus 10 is equivalent to 0. So we've got two solutions of x equals 20 and x equals 10. You will need to check if plugging x equals 20 and x equals 10 in to your values of a will return 0, because you can never have a number 0 to the 0, because that is undefined. So a to the b, where a and b are both equal to 0, will not work. And if you plug x equals 20, or x equals 24, sorry, and x equals 10 back into your a, they're not 0. So x equals 24 and x equals 10 are both valid solutions. Trying test case 2, if you set x squared minus 17x plus 71 equals to 1, then you're trying to solve the equation x squared minus 17x plus 70 factoring equals 0. Sorry, factoring this quadratic gives x minus 7 times x minus 10 equals 0. So we have two roots, x equals 7 and x equals 10. We've already got this solution here of x equals 10, so the only new one is x equals 7. No matter what values of x, given they're real, when you plug them into the exponent, they will always give a real number, and that's the only condition for case 2, so we know x equals 7 is a valid solution. Now, taking case 3 into account, where x squared minus 17x plus 71 is equivalent to minus 1, this gives the following quadratic of x squared minus 17x plus 72 is equivalent to 0. The simple factorization of x minus 9 and x minus 8 will give the roots x equals 9 and x equals 8. We will need to check if we plug x equals 9 and x equals 8 into the exponent if they give an even or an odd number. So when you plug x equals 8 in, you get b is equal to 32, which is even. So that means therefore x equals 8 is a valid root. And when you plug x equals 9 in, you get an odd number. Therefore, this is odd. Therefore, x equals 9 is not a valid root. So x equals 8, x equals 7, x equals 10 are the three and x equals 24. So we've got x equals 7, 10, 24, and x equals 8. And the original question asked what's the sum of these roots, and the sum of the roots are 49, and that is your final answer.